All right, in this lesson we are going to look at solving quadratic equations. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a cannot equal 0. This form is called the standard form of a quadratic equation. The graph of a quadratic function is a U-shaped curve called a parabola, which we looked at graphing those types of functions earlier this year. And the solutions, or x-intercepts, are often called the roots of the equation, or zeros of the function. Below are some examples of the graphs of quadratic equations. In the first one, we have x squared minus 4 equals 0, and if you recall, we graphed these types of graphs, but we saw them as y equals x squared minus 4. These type of equations have two solutions, and in our first example, our solutions are positive and negative 2. That's where our parabola is intercepting the x-axis. In the second one, x squared equals 0, which is the same as the function y equals x squared, there's only one solution at 0. And then x squared plus 4 equals 0, or y equals x squared plus 4, there are no x-intercepts, and for our purposes right now, we have no solution. So there's more than one way we can solve these types of equations. The first way we looked at in the past was graphing them, and we got our parabolas. A second method we could do is by solving for x by taking the square root. So in number 1, we have x squared minus 25 equals 0. Well, I first need to get x squared by itself before I can take the square root. So if I add 25 to both sides, I have x squared equals 25. Inverse of squaring something, taking the square root. Square root of x squared is just x. Now square root of 25 is 5, but it could be positive 5 or negative 5. And that's how we get our two solutions. So if I were to graph y equals x squared minus 25, my parabola would intercept the x-axis at 5 and negative 5. All right, number 2, 2x squared minus 98 equals 0. So again, solving for x squared. Let's add 98. So we have 2x squared equals 98. Divide both sides by 2. So x squared equals 49. And last, take the square root. So x can be positive or negative 7. All right, how about number 3? Let's subtract 2. We get 2x squared equals negative 2. Divide by 2. So x squared equals negative 1. And the inverse here would be to take the square root. If you recall, can we take the square root of a negative? No. So here we can say this is not real, right? This would be not real. So therefore, number 3, I have no solution. This equation, if I were to graph it, would not intercept the x-axis. All right, finally number 4. All right, solving for x squared, let's divide by 49. So x squared equals 9 divided by 49. And then take the square root. Remember, square root of a fraction is same as square root of numerator, which would be 3, over square root of denominator, 7. So x equals positive or negative 3/7. So far we looked at graphing and solving for x by taking the square root. The last method that we could use to solve these equations would be to factor. So the zero product property tells us for every real number, a and b, if a times b equals 0, then a equals 0 or b equals 0. So for example, if x plus 3 times x plus 2 equals 0, So these would be our factors. Let's say we factored and got that. Then I could say that x plus 3 equals 0, x minus 2 equals 0, and then we'd solve both equations. Here we would get x is negative 3, and here x is negative 2. So let's look at these first two examples. So if you factored, and your factors of your trinomial were x plus 7 and x minus 4, we'll then set each factor equal to 0, and then solve each equation. So now we have two equations we could solve. The first one, you subtract 7, you get x equals negative 7. And the second one, add 4, so x equals 4. And there are your two solutions. Same idea in the second one. 3x minus 5 could equal 0, or x minus 2 could equal 0. So let's see, add 5. 3x equals 5, so x is 5/3, or x equals positive 2. Alright, now let's go back a step and practice some factoring. So in these examples, we want to factor first and then solve for x by setting each of our factors equal to 0. Number 1, we have x squared minus 8x minus 48 equals 0. So if you recall, make your two sets of parentheses. This time it has to equal 0 at the end. We're thinking of factors of negative 48 that will add up to negative 8. So factor x squared, we have x and x. Well, factors of negative 48 that add up to 8, positive 4, negative 12. Okay, so let's set each of our factors equal to 0. Alright, on the left, subtract 4, so x equals negative 4. And on the right, add 12. X equals positive 12. Alright, how about number 2? Again, factor. Alright, two sets of parentheses equals 0. You factor x squared, x and x. Factors of negative 42 add up to positive 1. Good. Positive 7, negative 6. Then set each of your factors equal to 0. Okay. Solving for x, we have x equals negative 7, or x equals positive 6. Good job. Alright, let's see, number 3. So if you notice, number 3 is not set up like our other two. This time it says x squared minus 12x equals negative 36. Well, let's first get my equation equals 0. So just add 36. Right, we're going to bring it over to the left. If you can't combine it, just write it next to our x term. Alright, same thing like above. We're going to factor. Factors of positive 36 that add up to negative 12. So let's first factor x squared. I know my signs will both be negative. And it's 6 times 6 that adds up to 12. So set both of your factors equal to 0. And you also notice something else a little different here. On the left, I get x equals 6. And on the right, I also get x equals 6. So for our quadratic equations, we're always getting two answers, just sometimes the answers are the same. Alright, number 4. Alright, let's see, 3x squared plus 24x plus 36 equals 0. If you recall, first thing from factoring, look for a GCF. In this case, that's a 3. So if I factor a 3 out first, I'm left with x squared plus 8x plus 12. Alright, keeping that 3 in front, let's factor our trinomial. So factors of 12 that add up to 8. Okay, so we got an x and an x. My signs are both positive. And that would be 6 and 2. Alright, so we're going to set all of our factors equal to 0. So 3 equals 0, which is not true, so we're just going to throw that answer out. So 3 is not a solution, but x plus 6 could equal 0, or x plus 2 could equal 0. So again, I'll still only get 2 solutions here. X could equal negative 6, or x could equal negative 2. Alright, last 3 examples, this time a little trickier with the factoring. Number 5, 4x squared minus 25 equals 0. So that's a little similar to the first example we did where we solved for x by taking the square root. So I could solve for x by taking the square root, or I could solve by factoring. So if you notice, both 4 and 25 are perfect squares. So this would be the difference of 2 squares. So 4x squared would factor as 2x and 2x. And 25 would factor as 5 and 5. And if we want to add up to a 0, we need different signs. So then let's set each of our factors equal to 0. Okay. First subtract 5. There we go. And then divide by 2. So x equals negative 5 halves. You could make that a decimal if you want, but I'm just going to leave as a fraction since we're not going to be graphing or anything. And then on the right, add 5 and divide by 2. Again, I'm just going to leave my answer as a fraction, but you can make that one a decimal since it's a terminating decimal. Alright, number 6. So let's see. First we need to get our quadratic equation in the correct order. So I'm going to bring the 21 to the other side, which makes it negative. Alright, then I look. Do I have a GCF? No. Alright, so we're going to factor. I am going to guess and check to factor because since my first term, this 3x squared, since 3 is prime, my only choices are 3x and 1x. Alright, now I'm thinking of factors of negative 21. So let's see, it could have negative 3 times 7, 3 times negative 7, and since my middle number is a negative 2, I don't think, well I highly don't think, that I'm going to use the factors 1 and 21. Alright, the only question here though is, which of these am I going to choose, and which parenthesis will I put them in? Alright, so going back to that I have a 3x first. I'm thinking, what could I put here? I want to multiply and not be too far off that when I subtract I get a 2. If I put a 7 in the second parenthesis, 3 times 7 is 21, it's going to be too big. So I'm going to put a 3, which means in this one's 7. Now, this is good because 3x times 3 is 9. So here if I multiply I'll get 9. And here if I multiply I get 7. If they need to add up to a negative 2, I'm going to need a negative and a positive. Alright, now if I solve for x, going back to what's new in this lesson, we're going to take each of our factors, set them equal to 0. Alright, so on the left, let's subtract 7. So 3x equals negative 7. Divide by 3. X equals negative 7/3, which I will keep as a fraction because that is non-terminating. Oh, and I just noticed, let's see, I put x equals 3 equals 0. Which the eraser doesn't want to work. Okay. This should just be an x minus 3. There we go. So add 3, you get x equals 3. Alright, last one. Again, let's rewrite this so it's in the proper form. So bring 5 to the other side, which makes it positive. Looking for a GCF. I don't have one. So make 2 sets of parentheses. Again, I'm going to guess and check here since 2 is prime and 5 is prime. So my only factors of 2x squared are 2x and 1x. And my only factors of 5 are 1 times 5. I also know my signs are both going to be negative since the 5's positive, but the 7's negative. Alright, so let's see. What could I put here that when I multiply by 2, it's not too big, but then I need to add up to a negative 7. If I put a 5, I'll get 10, which will put me over. So if I put a 1 and a 5, let's see. These two will multiply to negative 2. These factors will multiply to negative 5. And those add up to negative 7. So I'm good. Alright, going back to solving for x. So 2x minus 5 equals 0, or x minus 1 equals 0. Add 5, so we get x equals 5 halves. Or x equals positive 1. Okay, so that concludes our examples for solving quadratic equations. Go ahead and try the practice worksheet, and good luck.